Hello everyone. This is Kaidun Zhang from University of Science and Technology of China. Thanks for your interest in our work. The title of our work is Inertia-Guided Flow Completion and Style Fusion for Video in Painting. The code of this work is available on GitHub. Given a sequence of video frames and frame-wise masks, Video in Painting aims at filling in the corrupted regions across video frames to maintain the visual coherence of the restored video. It has wide applications, including watermark removal, object removal and video retargeting, etc. Different from image in painting, since we can access more complementary video content across video frames. How to explore these complementary video content is the key point in video in painting. What's more, the newly introduced temporal dimension poses another challenge. Here is our motivation. Since inertia exists in any object, the nearby optical flows are more correlated than the distant flows. Therefore, we exploit and aggregate the complementary regions from nearby optical flows explicitly for more accurate flow completion. Moreover, we observe style difference exists across different video frames. If we borrow the content from other frames directly, such style difference causes suboptimal video in painting quality. Therefore, we propose a two-stage network. Our method consists of 3 steps. In the first step, optical flow features are aligned under the inertia prior, and then fused for flow completion. Next, we utilize the completed flows with original resolution to guide the gradient propagation across the video. Finally, we adopt ASFN to correct the style of the filled gradients based on the style in the valid regions, and utilize pass-on blending to render the results. We first introduce our designed inertia-guided flow completion network, IGFC. IGFC is a U-net structure, inserted by an inertia flow warping module. The illustration of inertia flow warping module is shown at the bottom left corner. Inertia assumption assumes the motion pattern between corresponding points across nearby optical flows is identical. As shown in the bottom right corner, the introduction of inertia prior helps the network synthesize more accurate motion boundaries. As for the style correction module, we design a novel adaptive style fusion network, ASFN. ASFN is also a U-net structure, which consists of several ASF modules in the middle layer. The core component in ASFN module is the ASF block. We extract the mean value and standard deviation from valid regions to correct the corresponding style information extracted from the corrupted counterparts. This figure shows the effectiveness of ASFN. ASFN can improve the spatial coherence clearly. To reduce the training cost of ASFN, we design a novel data simulation pipeline. In data simulation pipeline, we only corrupt the gradient in the middle. The corrupted regions are filled by the flow-guided warping from its nearby gradients. We fuse these to gradient maps with the weight maps generated from the forward-backward consistency check of corresponding optical flows. The simulated gradient maps are used for ASFN training. Here we show the optimization objectives for IGFC and ASFN training. Here is the quantitative result table. We evaluate our method and the baselines with different type of masks on YouTube Voss and Davis. Our method achieves significantly improvement over the previous baselines. We also provide the frame-wise video-wise comparisons. For video-wise comparisons, please scan the QR codes at right. Thanks to IGFC and ASFN, our method suffers less warping error induced by inaccurate optical flows and less spatial inconsistency, as indicated in the yellow circle between our method and FGVC, which leads to more visual pleasing results. We also provide the comparisons of flow completion quality between our methods and the previous counterparts. Our method enjoys more accurate flow completion quality. Such accurate optical flows leads to more accurate flow-guided context propagation, which leads to better video in painting quality. For the evaluation of perceptual quality, we perform a user study to illustrate the superiority perceptual quality between our method and the current state-of-the-art baselines. Compared with other methods, the synthesized videos from our method is more favored by the volunteers. Here comes the conclusion. In this paper, we adopt inertia prior to exploit the complementary regions in nearby optical flows for the first time. Moreover, we first design the adaptive style fusion network to eliminate the style inconsistency for spatial coherence between the corrupted regions and the valid regions. For efficient training of ASFN, we design a novel data simulation pipeline. Finally, we perform extensive experiments to demonstrate our method achieves superior quantitative and qualitative results. Thanks for watching. Welcome to visit our project page.